Okay, the last step that I'm going to cover is how to calculate the center of flotation of your vessel. For this, we'll need another chart similar to the ones we used prior with using the Simpson's multipliers. This time, though, we're going to look at the beam of the vessel at your design water line. Our design water line is at 1 foot, so we'll be looking at the cross section here above. So if you look at the beam at each of these sections, the beam at section 0 is 0 because there's no breadth there. At section 1, it's 2 times 1/2, which gives you 1 foot. Put my units up here. And then at sections 2, 3, and 4, they are all 2 feet across there. Now we use our Simpson's multipliers again. This time 1, 4, 2, 4, 1. So those are our multipliers. Then we're going to multiply the beam of the vessel times the Simpson's multiplier. That will give us 0, 4, 4, 8, and 2. We need to total these values, and if you total them, you should come out with 18. And that is the summation of B times SM. The units for this are just feet. The next thing that we need to look at is the lever arm, X. The lever arm is measured from our reference point, which is at the bow. So if you look at section 0, the lever arm would be 0. At section 1, it's 1.5 feet from section 0, or from the bow, so it'll be 1.5, 3, 4.5, and 6. Now we just multiply the beam times the Simpson's multiplier times X, the lever arm. And then total it. Which will give us a value of 66. Once we have this, we can calculate the LCF. The center of flotation. Well, it is longitudinally because we're looking at the longitudinal lever arm. So CF will equal summation of B times SM times X divided by the summation of B times SM. Fairly similar format as you've noticed before for calculating LCB and VCB. We'll use a value here of 66 square feet divided by 18 feet. So for our CF, we'll get a value of 3.667 feet. Now you might notice that our CF is in the same location as a longitudinal center of buoyancy. That does make sense because the cross-section of the hull was kept the same throughout the different water planes, and so it did not change. Your shape will change because you'll want to have more curvature towards the bottom of the vessel. So your LCF and your longitudinal center of buoyancy will not be the same. One other thing to note is that you can use this table to calculate the area of the water plane using Simpson's rule. So this is the same type of format that you can use for that.